Now, if we have x and y values, as in this table here, where we understand x to be measured in centimeters and y measured in pounds, and we don't know what's being measured, you know, I was thinking in terms of the force exerted by a spring as you pull it further and further out. And that's one perfectly good interpretation, but we don't need that interpretation. What we want to do is we want to specify the slope of the fundamental triangle for these 2 points in terms of these interpretations. So that what we have is a fundamental triangle with the point 3, 2 and the point 7, 12. I'm not going to write out the calculations. Clear that from 3 to 7 the displacement is plus 4, so the run is 4. And from 2 to 12 the displacement is plus 10, so the rise is 10. Now, given the meanings of x and y, the run goes from 3 centimeters to 7 centimeters. So this 4 actually represents 7 centimeters minus 3 centimeters, or 4 centimeters. And the rise is 12 pounds minus 2 pounds equals 10 pounds. So that the slope which is rise divided by run, 10 over 4, or 2.5, the meaning of the slope is 10 pounds over 4 centimeters, which is 2.5 pounds over centimeters. Okay? And we read that as 2.5 pounds per centimeter. If we're thinking of a spring, that represents every centimeter we pull it back, we get 2.5 pounds more resistance, 2.5 pounds more force pulling back toward the center. Now, this is a typical way we begin the interpretation of a graph. We interpret its slope. We interpret what its y value means. We interpret what its x value means. So its slope means, well, whatever the y quantity is divided by whatever the x quantity is, or the change in the y quantity divided by the change in the x quantity. Okay, the rise is the 10-pound change in the y coordinate The run is the 4 centimeter change in x. Slope is rise over run, which is change in y. Over change in x. And again, that equals, I've already written it down, but just to emphasize, 10 pounds over 4 centimeters, 2.5 pounds per centimeter. And this is a rate of change. Of the Y quantity, the Y quantity with respect to the X quantity. And this is an extraordinarily important concept. It's actually a fundamental concept of calculus when you take this average rate of change to a limit in a way that we're not going to talk much about in this course.